Hello, and today we're going to be talking about associativity. What is associativity? Associativity is when things are grouped together without changing the order. If that doesn't make sense, don't worry. The following examples will help explain it. The first example we're going to look at is the equation 2 plus 3 plus 10. As you can see, there are two ways to solve this. Either by adding 2 plus 3 together and then adding 10, or by adding 3 plus 10 and then adding 2. 2 plus 3 is 5, and when we add that to 10, it equals 15. This is one way to do the equation, by first adding 2 plus 3 and then adding 10. We can solve this equation another way, by first grouping together 3 and 10 and then adding 2. 3 plus 10 is 13, and adding 2 is 15. Despite the fact that we solve these equations in different ways using different order, we still get the same result of 15. This doesn't just work for addition, but for multiplication as well. If we look at the equation 4 times 5 times 2, if we first solve 4 times 5, that equals 20. 20 times 2 is 40. However, we can also solve the equation by first going 5 times 2, which equals 10, and then timesing it by 4, which equals 40. We get the same result both times despite using a different order. We're now going to go through some textbook examples. The first example is 234 plus 197 plus 103. Similar to what we looked at before, there are two ways that we can solve this. Either by adding 234 plus 197 first, or by adding 197 plus 103 first. Both methods work, however one is easier than the other. 234 plus 197 equals 431. Add that to 103 and it equals 534. However, we can first do 197 plus 103, which equals 300, plus 234 equals 534. Both methods still give us 534, but adding 197 plus 103 is easier than adding 234 plus 197. So while both methods work, sometimes changing the order in which we add the numbers together makes the process easier. Similar to the last example, we're going to do 14 plus 17 plus 6. However, in this example, you can see that the numbers in the second example change the order. Instead of following 14 plus 17 plus 6, it's now 14 plus 6 plus 17. Because we know that changing the order doesn't matter, we can change the order in which the numbers align. So the first example adds 14 plus 17 first, while the second adds 14 plus 6. 14 plus 17 equals 21, plus 6 equals 27. The second one, 14 plus 6 equals 20, plus 17 equals 27. Both equations give us 27, but the order in which we do it is different. 14 plus 6 is easier to solve than 14 plus 17. So most people will use the second route. So while both are valid, the second one is simply easier to do. And notice how we changed the order, because we know that it's going to be the same result, no matter which way we decide to go with it. The third example is 12 times 35. 12 times 35 is a hard equation to solve automatically. So instead, we can break down 12 into 6 times 2. That gives us the equation 6 times 2 times 35. This is the exact same equation as 12 times 35, because we know that 6 times 2 is 12. However, because we broke it down, we can rearrange the way that we put the numbers together in order to solve the equation. So while initially 6 times 2 was together, this time we can first do 2 times 35, which is 70, then times it by 6. 70 times 6 is 420. By breaking it down and changing the order in which the numbers go together, it becomes easier to solve rather than sticking with the original equation and trying to solve 12 times 35. Our final example is 8 times 1769 times 125. This is similar to our second example. 8 times 1769 is a hard equation to solve. Similarly, 1769 times 125 is not an easy thing to solve. Instead, we can rearrange the order in which these numbers are and make it 8 times 125 times 1769. 8 times 125 is easier to solve than 8 times 1769 or 1769 times 125. 8 times 125 is 1000, and 1000 times 1769 is 1,007,069. So by rearranging it, this becomes easier to solve than sticking with the original order. However, associativity does not work with subtraction and division. We looked at multiple examples where it did work in addition and multiplication, but the same rules do not apply for these two. For example, if we take the equation 50 minus 25 minus 2, 50 minus 25 is 25, minus 2 is 23. If we rearrange the order and the equation becomes 25 minus 2 minus 50, 2 minus 50 is 48, and 25 minus 48 is negative 23. Despite using the same rules as before, we get different answers because the signs are now subtraction. Hence, associativity does not work when it is subtraction. The second example uses division. 20 divided by 10 divided by 2. 20 divided by 10 is 2, and 2 divided by 2 is 1. If we group the second and third number together first, so 10 divided by 2, that gives us 5. And 20 divided by 5 is 4. Despite using different groupings, we get different answers, something that didn't happen with the other examples. This is proof that division does not